Good morning, dear students. Welcome back again with the new session of Science lesson number 16, Reflection of Light. Today we are going to discuss about reflection of light. Your first 11 lines have been omitted for this syllabus. So we'll start directly with reflection of light. When light rays falls on the object, the direction changes and they turn back. This is called as reflection of light. In order to study about reflection of light, the material used is torchlight, mirror, a stand for hanging the mirror, black paper, comb, white paper, drawing board, etc. Now, how the activity is to be performed? Fit a white paper tightly over a table or drawing board. Leave the same portion in the middle of the comb. Cover the rest with black paper so that light can only pass through the central portion. This is similar to page diagram 16.1. Hold the comb perpendicular to the white paper and throw torchlight on its central portion. Adjust the comb and torch so as to get light rays on the white paper. Now keep the mirror in the path of the ray of light as shown in the figure. What do you observe? In this activity, light rays falls on the mirror, get reflected and travel in a different direction. The rays light on any surface are called as incident rays. The point at which an incident ray falls on the point is called point of incidence. The rays going away from the surface after reflection is called as reflected rays. Direction of the reflected rays decided by some rules which are called as laws of reflection. Let us learn some definition before learning about these laws. As shown in the figure 16.2, in order to study the law, we have to follow the steps. Draw a line PQ showing the position of the mirror. Draw a line incident ray AO and the reflected ray OB. Draw a perpendicular to the line showing the position of the mirror, that is PQ at O. This line ON is called normal to the mirror as ON is perpendicular to PQ. Now, as per the diagram in front of us, certain laws has been said. Now, what are these laws? There are three laws of reflection. These are as given below. First law, angle of reflection is equal to angle of incidence. That is, I is equals to R. Then, second law, the incident ray, the reflected ray, and the normal lie in the same plane, on the same plane. Means all three, incident ray, normal, and reflected ray, they all lie on the same plane. They are coplanar. The incident ray and the reflected ray are on the opposite sides of the normal. These are the three laws of reflection. Now, some terms related to reflection are as follows. Ray AO is the incident ray, point O is the point of incidence, ray OB is the reflected ray, line ON is the normal. The angle AON between incident ray and the normal is the angle of incidence I. Angle BON between the reflected ray and the normal is the angle of reflection. Equipment for the next activity: mirror, drawing board, pens, white paper, protractor, scale, pencil. Now, what is the activity? Fit a white paper on a drawing board as tightly as possible. On the drawing paper, a line PQ indicating the position of the mirror 16.3. Draw a figure ON to PQ at point O. Draw a ray AO making an angle of 30 degree with ON. Fix 2 points S and R along with AO. Fix the mirror to a stand and place it along PQ perpendicular to the drawing board. Fix pins at T and U along the line joining the bottom of the reflected images of the pins at S and R. Remove the mirror and join the points T and U and extend it up to O. Measure angle TON. Repeat steps 4 to 9 for angle of incidence equals to 45 degree and 60 degree, and write down the angles in the following table. It is observed that angle of incidence will be equal to angle of reflection. Therefore, angle R will be 30, 45, 60 degree respectively. From this, what relation do we find between the angle of incidence and angle of reflection? We found that angle I and angle R both are equal. If you have done the experiment carefully, you will find that angle of incidence is equal to angle of reflection in all the three cases. This verifies law of reflection. What will happen when the light ray is incident perpendicular to the mirror? It will reflect back in the same direction. That is, it will retrace in the same path. Figure 16.4 A and B show three parallel rays shown in blue incident on smooth and rough surfaces. The reflected rays drawn using show reflection. Rays reflected from which surface are parallel to one another. Now, if it is plane surface, the reflected rays and the incident rays both are parallel to each other. What conclusion can you draw from the figure? We can infer that angle of incidence and angle of reflections both are equal when the surface is smooth. What in case if surface is not smooth, rough? Under that condition, angle I and angle R does not appear to be equal. Therefore, law of reflection is only applicable in the smooth surface but not in the rough surface. Regular reflection of light. The reflection of light from a plane and a smooth surface is called as regular reflection of light. For regular reflection, angle of incidence as well as reflection are the same for all parallel rays falling on the surface. Thus, the reflected rays are also parallel to one another. If the angle of incidence for angle of incidence rays are I1, I2, I3, and the angle of reflection are R1, R2, R3 respectively, then I1 equals to I2 equals to I3, which is equivalent to R1 equals to R2 equals to R3. Refer to figure 6.16.4a. Now, irregular reflection of light. The reflection of light from the rough surface is called as irregular reflection of light. In irregular reflection, angle of incidence for parallel rays of incidence ray are not equal, and therefore angle of reflection are not equal. So here I1 not equal to I2 not equal to I3, and therefore R1 not equal to R2 not equal to R3. Thus the reflected rays are not parallel to one another and spread over a large surface. This is clear from the figure 16.4b. So, with the help of this experiment, what we are supposed to remember? Law of reflection are followed in both regular and irregular reflection. Reflection of light in regular reflection has not been obtained because law of reflection are not followed. They are obtained because the surface is rough, irregular. In irregular reflection, angle of incidence at different points are different. but at any point, angle of incidence and reflection are equal. That is, I1 equals to R1, I2 equals to R2, and so on. What do you see if the barber in a saloon has cut the hair on your neck properly or not? What type of image do we see in a mirror? Definitely it is a plane. So same image and mirror both are object and mirror image are same. What happens to the left and the right sides? Left is implying the right and right is implying the left. So how do we see the image of the moon in water? In saloon, there are mirrors in front and at back. The image of the back of your head is formed in the mirror at the back. The image of this image is formed in the front of the you. Thus you can see how hair at the back side of your head is cut. How do we see the image of moon in water? As moon is not self-luminous, the sunlight falling on the surface of the moon is reflected. This reflected light is again reflected by water to give us the image of the moon. In this way, light can be reflected several times. Now, another activity, that is kaleidoscope, that can be prepared with the help of mirrors. Take three rectangular mirrors of the same size. Using sticking tape, stick the mirrors together, making a triangle with reflecting surface facing inwards as seen in the figure 16.5. Take a white paper of a triangle and fix it with the tape at one end of the mirrors, closing that end. Insert 4 to 5 colored glass pieces in the hollow of the mirror. Close the other end and also with the paper and make a hole in it. Look through the hole towards light. You will see innumerable images of the glass pieces. These are formed due to the reflection of three mirrors. You can see different designs in the kaleidoscope. The specialty of the kaleidoscope is that the designs do not easily repeat themselves. Every time the design is different. People making wallpapers which are used to decorate the walls and clothes designers use kaleidoscope for making the new designs. Periscope. Now, how to perform the activity for the periscope? Take a cardboard box, make the slits at the top and the bottom of the sides of the box, and place two mirrors so that they make an angle of 45 degrees with the sides of the box and they are parallel to each other. Fix them with the sticking tape seen figure 16.6. You can see the mirror are parallel, up and down both are parallel, making 45-degree angle with the cardboard, both at the top as well as at the bottom. Make two windows of 1 inch near the two mirrors. Now see the bottom window. Make a note of what you see. From the bottom window, one can see what is in front of the top window. One can see what is in the front of the top window. This device is called as periscope. This is used in the submarines to see the objects above the surface of the water. It is also used to observe and keep a watch on the objects or person on the ground from an underground bunker. Kaleidoscope and periscope both use the properties of reflection of light. Here we have completed the lesson of reflection of light. Remaining other lessons we will do it in the next video. Till then, have a great day. Take care.